Okay, guys, I'm gonna try one more time. Let's see if it can be a little quieter this time over here. All right, so now we are selecting all logarithmic expressions that are equivalent to log of 36. Okay, so let's see. Okay, so I can already tell the good ones and the bad ones. Let's decide what's the best way to explain it. That first one, this one's a scam. All right, this one is a scam, you guys. So listen, we know that 36 is 6 squared. So instead of log of 36, we could have said log of 6 squared, right? But what this is log of 6 squared. It is not log of 6 all squared, right? So this is bad. It's a scam. Don't fall for the scam, all right? Okay, this one. This is log of 12 plus log of 3. So when we are adding two logs, we know that we could combine this into a single log as long as we multiply the inside. So 12 times 3, which is 36. This one is good, not a scam. This one, kind of a scam. They're messing with you. You see this one and you see this one? Only one of them is log of 36, all right? And it's not this one. When we have a number multiplied in front of a log, what we can do is bring it to the exponent. So what it becomes is log of 2 to the 6th power, or in this case, log of 6 to the 2nd power, all right? Well, 2 to the 6th is 64. This is log of 64. And this we already earlier figured out. So this is log of 36. This one is good. This one's a scam. No, that one was a scam. This one is just a little tricky. Okay, now here we are. 2 logs, and we're subtracting, all right? The bases are the same. That's the key. Don't just think any 2 logs, but 2 logs of the same base. We're subtracting. We can combine this into a single log. Subtraction means, though, that I have to divide 72 by 2. So 72 divided by 2, and that is 36. All right. That was fun. Oh, they want me to write another one equivalent to log of 36? No problem. I got like a bazillion. How about ln of 36 divided by ln of 10? That was change of base formula, you guys. Remember change of base formula? And you can literally do this with any log you want, all right, top and bottom. That's if you wanted to go the change of base route. If you want to go the combining logs route, there's I can't say there's even more because they're both infinite. We can go log of, how do we want to break it up? Do we want to go 18 and 2? Do we want to go subtraction and go like log of 360 minus log of 10? So many things, you guys. So many things you can do. All right. I think I made my point. Let's move on. Here are the values of 3 different logs. Ooh, love these types of questions because they seem like, what? What are you talking about? Right? But then you go, oh, that's it? So I like those. It tells us that log of 2 is about 0.3. Log of 5 is about 0.7. And log of 16 is 1.2. So then they want me to use these approximations to evaluate 4 of these, but let's see how many I get to. Okay, here's the deal. You see this calculator? It can do every single one of these problems. Guess what we're gonna do? We're gonna throw it away and not use it, all right? Well, don't throw it away, that's wasteful, but do not use it because they want you to use these. Like, watch. Log of 5 over 2. I can rewrite this, right? This is 1 log with division. That means it started out as 2 logs with subtraction. This was log of 5 minus log of 2. And you know, 2 logs, we did this earlier, right? They combine as long as you divide, see? And then now, log of 5, I know what that is, that's 0.7. And log of 2, I know what that is, that's 0.3. All right, so what does this guy approximately equal? 0.4. All right, fun, right? So fun. Here's another one, check it out, log of 4. You might think, whoa, they didn't give me 4. I guess they gave you 16 and 2. So you could divide 16 by 2 and get 8, and then divide it by 2 again to get 4. However, even easier than all of that is to rewrite this as log of 2 squared. Log of 4 is log of 2 squared, or log of 2 times 2, whatever you want to do. If you did the 2 times 2 route, you would break this up into 2 logs. But with the way I did it, with the square, all you got to do is drop this 2 as the exponent out front. This is 2 log of 2, which is 2 times log of 2 is 0.3. So this is just 0.6. All right. Okay, 32, I would say, is 16 times 2. So I would rewrite this as log of 16 plus log of 2, because that's what would make me multiply these to make the 32. Log of 16 is 1.2 plus log of 2 is 0.3. That makes this one equal to 1.5. Log of 25, I would rewrite as log of 5 squared. 25 is 5 squared. Drop the 2 out front. 2 log of 5. And then there you have it. Boom. Drop in the 0.7. This is about 1.4. 8, I would absolutely, having 2, I would rewrite it as log of 2 to the 3rd and drop the 3 out front to do 3 times 0.3 to get 0.9. But I want to let you know, if you went the log of 16 minus log of 2 route, because 16 divided by 2 is 8, you'd still get the same answer, because you would get 1.2 minus 0.3, which is 0.9. All right. Oh my gosh, I love when they do this. Here's the secret, you guys. Now you could make this happen. This bad boy right here. You could take care of this with the 2 and the 5 and try to make this 26, okay? But personally, I like to know that there's a secret log here that they don't show me. Imagine it's with invisible ink over here. And it's that log of 10 is 1, right? Because the base of this is 10. Log base 10 of 10 is 1. I always remember the base of the log. So what I would do here, personally, you guys, is to simplify 2 over 20 to make it 1 over 10. Which then I would rewrite with the base as 10 to the negative 1. And then whoosh, whoosh, negative 1. Fun times, all right? Okay. I'm trying in my head now to see, though, if you did these, if it would have came out the same. It should. I'm just gonna move along. Okay, now we're looking at task F, rewriting each expression using a log base 10 or an ln. I'll do both, how's that? This is log base 10 of 20, divided by log base 10 of 5. All right? Or ln of 20 divided by ln of 5. You guys, it's bugging me, by the way. Let me correct it here. When I did this, that I put an approximately symbol there. That's an equals. All right, this is equal to this. They're identical. It's not an approximation until I punch it into the calculator and round, okay? So that being said, these are completely equal to that, all right? This one, log base 2 of 10 divided by 5. I would make this, would I make this a 1/5 in the front, I think, you guys? I would make it a 1/5 log base 2 of 10. I don't like that divided by 5. And then what I would do is just go 1/5 log of 10 divided by 5 log of 2. I'm trying to think of so like see 1/5, this is like the numerator stays with the numerator, which is a 1, and the denominator stays with the denominator, boom boom, okay? But now you guys, we're at a place where this is a log base 10 of 10, which simplifies to be just 1. So now this is 1/5 log of 2. And that's where the story ends. That's all. We're done here. Okay. They want me to choose 3 of these and solve them. I'm trying to decide if any of them are like super worthwhile. I think maybe some of these multi-step ones are gonna throw you guys off. Some of these other ones, I don't see the difference between them and what I did here. You see, like, divide the 5 and then solve it the way I did these problems, okay? So I'm not gonna do this one. It's too similar to stuff we've done. I think I'm just gonna do this one for sure. I think I'll do this one. I'll do this one. And they said choose 3. Those are the 3 I choose, all right? I'll choose the 3 that I think would give you the most trouble. So here's what I'm gonna do, you guys, for C. 5 to the negative x plus 2 equals 18. Step 1, the first thing I'm gonna do is get rid of the fluff. I'm gonna subtract that 2 from both sides to get 5 to the negative x equals 16. Now you guys, you could log both sides or ln both sides right here, and that's a completely legitimate way to do it, especially since they wanted you to, right? Get your final answer as a log or ln. However, that is still not my preferred way, okay? I think my way is superior to the other way because everybody thinks they're right, right? So I like to use a log of the same base as my exponential base on both sides, or to rewrite as a exponential, as a log. So how would that look? It would look like a log with the same base, but then these numbers swap. Log base 5 of 16 equals negative x, all right? And now I'm so close to solving for x, I just have to divide both sides by negative 1, or same thing would be to multiply both sides by negative 1, whichever one of these you want, not both. Either way, you end up with x equals negative log base 5 of 16, okay? And now, I personally think it's pretty chill to say this equals negative log of 16 over log of 5, or that it equals negative ln of 16 over ln of 5. So just change a base formula here. to turn it into the logs they wanted. All right, I think that's easier. I like it better. Okay, let's look at E. 2 to the x plus 2. Ah, this is so similar to the one I just did. Why did I do both of these? Silly me. Here we go. We're going to add this 5 to both the sides, and we're going to get 2 to the x plus 2 equals 25. And then now rewrite it as a log. You know what? Since I am doing a problem so similar to the previous one, why don't I switch it up? I could rewrite it as a log just like I did here. I would write log base 2 of 25 equals x plus 2. And from here, I would subtract the 2, not from the 25, but just from the end, and then rewrite the log, okay? Using change of base. I'll do this a little different for you guys this time though. I'll do it the way this would have been if you did do the log of both sides right now, or the ln of both sides. It doesn't matter which you do, they're gonna come out exactly the same. So I'm gonna do log of both sides. However, if you do ln of both sides, everywhere that I have a log, you'll have an ln, everything else will be the same. Here's what that means, log both sides. It means I log this side, and I log this side. Okay? Now, this log doesn't get rid of this 2, all right? It doesn't bring me to a simple step like this did, all right? What it does do is it allows me to take this exponent and drop it out front to get x plus 2 in parentheses log of 2 equals log of 25. Now this is just a number, log of 2. So since I want to solve for x, I'm going to divide the log of 2 over. I want it out of here. All right, which if you notice right now, this cancels, and I have x plus 2, same as what I had here, equals, this is change of base formula here. You see it? So now we've ended up basically where we were here. X plus 2 equals log of 25 over log of 2. And the last thing I got to do is subtract 2 from both sides. All right? So we get x equals log of 25 divided by log of 2 minus 2. Okay? Same thing I would have gotten here. I would have subtracted 2, kept it separate from the 25, and then I would have changed a base formula this. And again, if you did ln instead of log, everywhere I have the word log, you would have ln, 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 ln. Everything else would be the same. Okay. Now let's look at f. All right, boop, boop, boop. I'm not gonna do this again, you guys. This is not my preferred way of solving, but I told my students, I remember in my higher level math classes, there was a pretty decent split of students who preferred doing it this way and students who preferred doing it my way. So you have seen both, you do what you want. Okay, here we are. Right here, there's no fluff. Like, there's no 5 to add to the other side, or negative 2 to divide, or 5 to divide, or 2 to subtract. Right? Like, this doesn't have any of what those ones I just showed you did. I know this exponent looks super complicated. I wish there was something I could do to simplify it right now, but guess what? There isn't. That's a lie. There is, but I'm not going to do it. All right? All I'm going to do is rewrite this as a log. A log base 3 of 90 equaling 4x plus 1. Okay? And now I'm just going to start solving for x. Log base 3 of 90 is a number. Okay? If this bugs you, you could rewrite it as log of 90 divided by log of 3. or ln of 90 divided by ln of 3 and get a decimal approximation and solve it, but then you wouldn't be following these instructions, okay? Let's keep ours like this. All I gotta do is subtract the 1. And then divide by 4. And looking at this mess over here, I wouldn't divide by 4 and go like all of this divided by 4, even though you could. I prefer what it looks like when you multiply by 1/4. So x equals 1/4 times log of 90 log of 3 minus 1, and I would leave it like that, okay? All right, you guys, I hope that was helpful. Good luck. This stuff really isn't, it's not as scary as it looks. I hope you're starting to see that and agree with that.